Imagine dedicating millions of dollars to build this incredible 200-mile-per-hour sports car.
Right, top of the line.
Exactly. You meticulously engineer the engine for like maximum acceleration, but then you completely forget to install a steering wheel.
Oh, that's a terrifying visual.
Yeah, you hit the gas and you are just hurtling straight into a brick wall. And honestly, that is exactly what many enterprise companies are doing right now as they rush to implement artificial intelligence.
It really is.
Welcome to techdaily.ai. I'm your host, David, and I'm joined by our resident expert, Sophia. Before we jump into things today, I want to let you know that you can sponsor this podcast for just $25. Your message will be featured across major platforms like Apple Podcasts, Amazon Music, Spotify, and more. If you're interested, visit techdaily.ai to get started today.
So getting back to that sports car analogy, the urgency out there is just palpable. Organizations are no longer debating whether to adopt these advanced AI models.
Yeah, that ship has sailed.
Completely. Now they're just scrambling to figure out how to do it without, triggering some massive, highly public disaster.
Which is exactly why today's conversation is focused purely on the practical architecture of safe AI adoption. We are looking really closely at a 5-step implementation framework utilized by Quisitive.
Yeah, and for some context for everyone listening, Quisitive was named the 2024 Microsoft Partner of the Year for Analytics.
That's just a huge deal.
It is. It means they're the ones actually in the trenches, right? They're wiring these systems up for Fortune 500 companies.
And our mission for you, our listener, is to basically bypass all that theoretical utopian or dystopian rhetoric. We're not doing that today.
No sci-fi today.
Exactly. We are going to unpack the actual mechanics of these 5 steps so you can walk away with a clear, jargon-free blueprint for enterprise implementation.
And to start, it really requires a fundamental shift in how organizations view software, because traditional software deployment is mostly deterministic.
Meaning you write the code and it executes the command.
Right. It does exactly what you tell it to do. But machine learning models are probabilistic. They infer, they predict, and they adapt over time.
Which changes everything.
It does. Because of that structural difference, the very first step in this framework isn't about choosing a server or picking an algorithm. Step 1 is establishing clear ethical guidelines.
And looking at the framework, this is fundamentally about risk mitigation. It's not about moral grandstanding or PR.
No, not at all.
It's about establishing operational boundaries to prevent bias and discrimination, maintain trust, and ensure regulatory compliance.
Yeah, you have to ensure the outputs are actually legally found. And the recommendation here points heavily toward adopting established paradigms, like Microsoft's responsible AI standard.
I was reading through that standard, and it is incredibly pragmatic.
It really is.
Yeah.
It forces an organization to define its operational red lines before a single line of code is even deployed.
Wow, so way early in the process.
Exactly. It mandates that teams evaluate fairness, reliability, privacy, and inclusiveness right from the start. It's basically a mechanism to ensure the tech performs predictably across diverse user groups.
Okay, but here's where I have a bit of a question.
Yeah.
The framework suggests enforcing this by creating an internal AI ethics committee, right?
Correct.
To conduct regular audits.
Yes, that's the recommendation.
But let's look at the reality of how enterprise committees operate.
Yeah.
Usually, a cross-functional team like that involves an HR director, a legal compliance officer, maybe the head of marketing.
Sure.
I have to playfully push back on the practicality here. We are talking about highly complex black box neural networks.
I see where you're going with this.
How is a group of non-technical executives supposed to audit a system with billions of mathematical weights and parameters? It feels a little bit like asking a neighborhood book club to perform a safety inspection on a nuclear reactor.
That is a great analogy, but the reactor comparison actually highlights a really common misunderstanding of what these committees do.
Oh, really?
Yeah. An oversight board isn't there to reverse engineer the Python code or adjust the hyperparameters of a large language model. They are practicing outcome-based auditing, not mechanism-based auditing.
Oh, okay. So they are testing the AI's output against the real world rather than trying to decipher the internal math.
Precisely that. Because, the engineers are entirely focused on optimization. They want to make the model faster, more accurate, more efficient.
Which makes sense. That's their job.
Right. But they suffer from a kind of technical tunnel vision.
Yeah.
You need the legal officer to look at the training data and ask, wait, do we actually have the intellectual property rights to use this? Or you need the HR director to review an automated resume screening tool and ask, Is the system inadvertently filtering out candidates who took maternity leave by penalizing gaps in employment history?
Wow, yeah. An engineer might totally miss that.
Exactly. The cross-functional team spots the operational blind spots that the engineers just aren't trained to look for. Ethics isn't just a coding problem, it's a human impact problem.
But an oversight committee is completely powerless if the foundation they are auditing is already poisoned, right? Which I think brings us to the causal link to the second step of the framework, understanding your current data estate.
Yes, absolutely. Data is the absolute foundation.
It is the raw fuel for that high-speed sports car we talked about.
The phrase garbage in, garbage out has been a computer science staple for decades. But with these generative AI models, it basically becomes bias in, scalable liability out.
Ouch. Scalable liability. That sounds expensive.
Very expensive. The AI is really nothing more than a mirror reflecting the historical data it was trained on. So if your foundational data is biased, the resulting AI will inherently be biased no matter how good the algorithm itself is.
Right. And the documentation points to this concept called the data maturity model to help organizations assess their readiness.
Yes, it's a very helpful framework.
But I think we need to unpack what that actually looks like in practice. Because honestly, data maturity sounds a bit like corporate buzzword bingo.
I know it does, but it's actually a very specific diagnostic tool. At the lowest level of the maturity model, let's call it the ad hoc stage, an enterprise's data is totally fragmented.
So like data silos everywhere.
Exactly. You have marketing data sitting in spreadsheets on someone's local hard drive, sales data trapped in some legacy CRM, and customer feedback buried in unsearchable email threads.
Sounds like a nightmare.
It is. If you point an AI at that environment, it will fail, or worse, it will draw very confident correlations from completely incomplete data.
Oh, like a model trying to predict customer churn based only on marketing emails, while completely ignoring the fact that customer service tickets have skyrocketed.
Which leads to terrible business decisions. So moving to the top tier of that model, the optimized stage, means the organization has constructed a centralized, governed data architecture.
Okay, so it's all mapped out.
Right. Every single piece of data has a clear lineage. The organization knows exactly how it was collected, what consent was provided, and who has internal access to it.
Strengthening that data privacy and establishing clear usage policies.
Exactly. Articulating how data is used and shared, both internally and externally, isn't just some IT chore. It is the absolute prerequisite for deploying enterprise AI.
Okay, so once that data is mapped, tagged, and secured, and the operational guardrails are established by the oversight committee, the organization is finally ready to enter the build phase.
Yes, getting into the kitchen, so to speak.
Which is the third step, adopting transparent AI development processes. And the key requirement mentioned here is documenting the AI workflows.
Which, I admit, sounds incredibly tedious to a lot of developers. But it is the ultimate safety net.
How so?
Well, transparency in the build process dictates that development teams must log their data sources, the specific model architectures they chose, and the exact decision criteria used during training.
It's kind of like running a commercial restaurant kitchen.
Oh, I like that.
If a chef refuses to write down their recipe or won't disclose the ingredients in their signature sauce, no one with a severe food allergy can safely eat there.
Exactly. It's a huge risk.
You have to document the workflow so the enterprise knows what's in the soup. But, the framework also emphasizes fostering open communication and engaging diverse stakeholders continuously throughout this development cycle.
Yes, very heavily emphasized.
And here is where I see a massive conflict. AI is valuable because of its velocity, right?
That's certainly a big part of the appeal.
So if developers have to stop and consult a massive group of stakeholders for every single iteration of a model, doesn't that inherently kill the speed of innovation? Aren't we just creating a bottleneck? Like too many cooks in the kitchen.
That tension between velocity and safety is arguably the defining challenge of the tech industry today. But documenting decision criteria and engaging stakeholders during the build isn't designed to slow the process down.
It's not.
No, it's a crisis management protocol. It's about accountability.
Okay, walk me through the mechanics of that. How does this documentation actually prevent a crisis?
Let's assume the organization deploys a dynamic pricing AI for its e-commerce platform. 6 months post-deployment, The system starts dramatically underpricing inventory during peak demand, costing the company millions.
A total disaster.
Right. If the developers were just moving fast and breaking things without logging their workflow or model choices,
Yeah.
the enterprise is facing an untraceable failure. They have no idea which training run or which specific data subset caused that anomaly.
So they would basically have to scrap the whole model and start over.
Exactly. But if they documented the workflow, they have a forensic trail. They can trace the failure back and realize, oh, on this specific date, we introduced a new variable related to seasonal shipping costs, and that variable disrupted the pricing logic.
Ah, I get it now.
You engage stakeholders early and log everything so that when the system breaks, and in highly complex probabilistic systems, it absolutely will break.
Right.
You have the map required to trace why it happened and patch it immediately.
That completely reframes the documentation from a bureaucratic chore into an agile recovery tool.
It really is.
But, deploying a transparent, fully documented model doesn't matter at all if the users don't know how to wield it safely.
That is the truth. The people matter just as much as the tech.
Which introduces the fourth step, promoting AI literacy across the entire organization. And the framework really stresses that this means all departments, right? Not just technical teams.
Yes, and this is where so many companies fail. They view AI as strictly an IT deployment, assuming that only the engineers need to understand how it works.
Right.
But the moment you integrate a generative model into your corporate environment, every single employee becomes an AI operator. Because these technologies are complex and rapidly evolving, you need ongoing learning programs and workshops.
And they point to some robust resources for building this literacy, specifically the free learning modules from Microsoft Learn and the National Institute of Standards and Technology's AI Risk Management Framework, NIST.
Great resources, highly recommend them.
But I want to play the skeptic again regarding the scope of this training.
Go for it.
Why does a copywriter or a logistics coordinator or an HR representative need to be, quote-unquote, AI literate?
It's a fair question.
I mean, I don't need to understand the combustion cycles of an internal combustion engine or how to rebuild a transmission to drive my car to the grocery store. I just press the pedal. So why does non-technical staff need to understand the mechanics of AI to use an enterprise chatbot?
I love the car analogy, but it actually highlights the exact gap in current corporate training. Promoting AI literacy is not about teaching a copywriter to be a mechanic.
Okay.
We aren't asking the logistics coordinator to learn Python or understand transformer architecture. We aren't teaching them to build the engine.
So what exactly are we teaching them if not the mechanics?
We are teaching them the rules of the road.
Oh, I like that.
Right. When you drive to the grocery store, you don't need to know how the transmission works, but you absolutely need to understand that ice on the road changes your stopping distance. You need to know what a blind spot is. You need to understand traffic signal.
That makes total sense.
Because AI models are fundamentally different from deterministic software like a spreadsheet, they require a different user approach. Everyday users need enough literacy to critically evaluate the AI's output.
Because of things like hallucinations and model drift.
Exactly. If everyday users lack AI literacy, they will treat an output from a large language model with the same blind trust they give a calculator.
Oh, wow. Yeah, they'll just assume it's perfectly correct.
They will assume the output is mathematically verified truth. Literacy training gives them the critical thinking skills to evaluate that output rather than trusting it blindly. They learn to identify confident-sounding fabrications.
And I imagine they also learn how to interact with it better.
Yes. They learn how to structure a prompt to constrain the model's creativity when they need factual retrieval.
It essentially transitions the workforce from being passive consumers of software to critical evaluators of probability.
Beautifully said.
Like, an HR rep drafting a policy document needs to know that the model might confidently invent a legal precedent that doesn't exist. And they need the literacy to verify that claim before publishing it.
It creates a human-in-the-loop safeguard. The most perfectly engineered model in the world is still a massive liability if the person reading the output doesn't know how to spot an anomaly.
That really paints a very clear picture of the implementation phase.
Yeah.
So we have our ethical guardrails, we've structured our data estate, we've transparently documented the development, and we've educated the workforce on how to drive the vehicle.
Sounds like a solid plan.
In traditional software, this is where the project manager pops the champagne and moves on to the next assignment.
Oh, if only it were that easy.
Right. Because the final step of the framework, step 5, shatters that illusion completely. Organizations must continuously monitor and evaluate the AI systems.
The finish line of deployment is actually just the starting line of management. An AI model is not static.
Not at all.
If you deploy version 1.0 of a word processing application, it remains version 1.0 until you deliberately push a software update. AI models, particularly those deployed in dynamic enterprise environments, are constantly shifting. They evolve and learn over time.
And the framework outlines specific ongoing actions for this. Tracking key performance indicators,
hmm
implementing user feedback loops to improve the systems, and the necessity of conducting regular continuous bias and fairness checks.
It's a lot of ongoing work to ensure systems remain secure and aligned with organizational goals.
It's also noted that Quisitive offers AI-managed services specifically because this continuous optimization requires dedicated, ongoing oversight.
Yes, many organizations need that expert guidance.
But let's explore why that constant supervision is mandatory. Comparing it to traditional software feels wrong. It's almost more like parenting. You don't just teach a toddler the rules once and walk away forever, right? You
Yeah,
have to constantly monitor their behavior.
parenting is a good one. Another analogy I love for this is running a botanical garden.
Oh, a botanical garden. Tell me more.
Well, you don't just plant a rare species in the ground, declare the garden finished, and walk away for a year.
Right, because the ecosystem is organic. The soil composition changes, cross-pollination occurs, invasive weeds take root, the weather fluctuates.
Exactly. If you aren't constantly pruning, testing the soil, and adjusting the environment, the garden just overgrows and destroys itself.
And in the context of an enterprise model, what is the soil?
The soil is the continuous stream of new data the system is processing. And this addresses the question of why bias checks must be continuous.
Because initially I was thinking, shouldn't a well-designed system have the bias engineered out of it from day one?
It's a logical thought, but even if the oversight committee engineered all historical bias out of the model on day one, the reality is the system is constantly interacting with the real world.
It's ingesting new market trends, shifting consumer behaviors, and interacting with entirely unpredictable human feedback loops.
And it is learning from those interactions. If we link this back to our earlier discussion about the data estate, your enterprise data is never frozen.
Right, macroeconomic factors change buying patterns, global events disrupt supply chains.
Yes, as the data estate evolves, the model adapts to fit the new reality. What was fair yesterday might develop new biases tomorrow.
Which means a predictive algorithm that was mathematically proven to be fair and unbiased in January could develop entirely new, unforeseen biases by November, simply by doing its job and adapting to new input.
Exactly. That phenomenon is known as model drift. The KPIs you are tracking, things like latency, accuracy, confidence scores, those are the sensors in your garden.
Ah, I love how this all ties together.
When a user flags a hallucination or the monitoring dashboard shows the model's confidence dropping on routine queries, the managed services team steps in to course correct. Continuous monitoring isn't a sign that the deployment failed.
It is an inherent requirement of operating a probabilistic system.
Exactly. It is a living, breathing asset that requires perpetual stewardship.
Wow. Let's pull all of this together for you, our listener, to cement the architecture of this framework. We started with the foundational blueprint, establishing clear, ethical guidelines to define those operational red lines, and utilizing a cross-functional committee to audit the real-world outcomes.
We then mapped the raw materials, understanding that an optimized, governed data estate is the non-negotiable fuel for accurate AI.
Moving into the build phase, we explored the necessity of transparent development processes, documenting the workflows to ensure any future anomalies can be traced and patched without catastrophic downtime.
We followed that by teaching the rules of the road, ensuring that every employee across the enterprise possesses the AI literacy required to critically evaluate outputs and spot those hallucinations.
And finally, we acknowledge that deployment is really just the beginning, requiring continuous monitoring, KPI tracking, and user feedback loops to manage model drift and adapt to a constantly changing environment.
It's a comprehensive journey.
It really is. Whether you are a corporate leader architecting a massive enterprise rollout or an employee navigating these new tools in your daily workflow, understanding this 5-step structure demystifies the process. It transforms artificial intelligence from a chaotic, daunting black box into a safe, manageable, highly effective asset.
It replaces reactive panic with proactive architecture.
It finally provides the steering wheel for that high-speed sports car.
Well said.
But before we sign off, I want to leave you with one final, slightly provocative thought to mull over on your own.
Oh, I'm intrigued.
We spent a lot of time discussing that final step, right?
Mm.
The necessity of continuous human oversight to monitor these systems, track KPIs, implement feedback loops, and prune the botanical garden.
Yes, crucial step.
But as these enterprise models become exponentially faster, more deeply integrated across global networks, and vastly more complex, are we rapidly approaching an inflection point where human oversight simply won't be fast enough?
Oh, that is a heavy thought.
Will we soon reach a reality where organizations have to build and deploy entirely new AI systems whose sole dedicated purpose is to autonomously monitor, evaluate, and enforce the ethics and operational boundaries of our current AI?
The concept of autonomous oversight algorithms. Who watches the watchers when the watchers are operating at the speed of light?
Exactly. Something to ponder the next time you type a prompt into your enterprise workflow. Thank you so much for joining us for this conversation on techdaily.ai. We love breaking down these complex topics with you. Until next time, stay curious and stay informed.